Okay, students, good morning to one and all. It's myself, Vijay Shankar from Electronics and Communication Department at Chevrolet Engineering College. Today, we are going to discuss about the properties of Fourier series. What are the remaining properties? We already discussed about the properties of Fourier series. So one is linearity property. Second one is time shift property. And third one is frequency shift property. Fourth one, scaling property. And fifth one is a time differentiation property. And in the last class, we discussed about the two properties. So mainly is a very, very important properties there. Those are convolution in time and convolution multiplication in the time. Convolution in time and multiplication in time, or multiplication or the modulation theorem. So up to that we completed in the previous classes. Now you go for the next property, that is Parseval's theorem. Parseval's theorem. See the statement of the Parseval's theorem saying that if x of t is a periodic power signal, the Fourier series are used to analyze for the periodic signals. So we are taking here the signal x of t is a periodic power signal with the Fourier coefficient x of k, with Fourier coefficient x of k. Then the average power in the signal is given by the sum of k equal to minus infinite to infinite, the squared magnitude of x of k. That is, I have to show that the average power P is equal to sum of k equal to minus infinite to infinite, the squared magnitude of x of k. We have to prove this average power of a signal is given as a squared magnitude of x of k with the sum of minus infinite to infinite by taking the x of t is a periodic power signal with the Fourier coefficient x of k. We already know the classification of signals is analog and the discrete. Analog means continuous time signals and discrete time signals. Again, if they are classified, they classified into periodic, non-periodic, even and odd signals, deterministic and random signals, causal and non-causal signals. And another one is the energy and the power signal also. Energy and power signals, energy in continuous time signal and power also in the continuous time signal, and energy and power in the discrete time signal also. Here we are using to prove the average power of the signal is given sum of k equal to minus infinite to infinite, the squared magnitude of x of k, by taking the signal, the power signal P is equal to, as a continuous, because x of t is a continuous time signal, P is equal to limit t tends to infinite 1 by t integral minus t by to the t by 2 x of t square dt. So actually without a limit t tends to infinite 1 by t here, integral minus infinite to infinite or integral t or integral minus t by to the t by 2, x square of t is the energy signal. X square of t is energy signal. See, without this limit t tends to infinite, 1 by t is only for the energy signal. It is energy E is equal to, with the limit t tends to infinite, 1 by t with energy signal, call it as the average power signal P. Average power signal P. By taking this power signal in the continuous time signals, 1 by t integral minus t by 2 to t by 2, the squared magnitude of x of t dt for periodic signal. For periodic signal, you can take it as a magnitude one. Okay, the magnitude here. And this magnitude we can written as, see here, the x of squared magnitude of x of t is a combination of a real term signal x of t and the complex signal x star of t. Following my dear students. So actually the combination of x of t into x of t is the x square of t here itself. X square of t is a different, and magnitude of x of t whole square is a different. If it is x of t square means x of t into x of t. X of t into x of t. But the squared magnitude of x of t is equal to x of t and x star of t. The combination of the real and the complex signals of both. Now, I'm replacing this squared magnitude of x of t square as x of t x star of t dt. X of t x star of t dt. How it becomes of magnitude, square magnitude? Because it is a periodic signal. As a definition saying that the power is equal to limit t tends to infinite 1 by t, the integral minus t by t, the t by 2 x square of t dt. As it is a periodic signal, I'm taking the 1 by t, the integral minus t by t, the t by 2 squared magnitude of x of t dt. I'm changing this squared magnitude of x of t as x of t x star of t dt. In this, we already know the x of t is equal to, is a synthesis equation. X of t is equal to sum of k equal to minus infinite to infinite x of k e power plus jk omega naught t. Analysis equation we already know. Analysis equation is x of k is equal to integral minus t by the t by 2, or within the limits of t. Input is x of t here. X of t e power minus negative exponential jk omega naught t dt. We are using this exponential Fourier series. One is analysis equation, another one is the synthesis equation. Using this synthesis equation, x of t is equal to the sum of k equal to minus infinite to infinite x of k e power jk omega naught t. Taking both sides as a conjugate, on both sides the conjugate becomes of x star of t is equal to whole sum of k equal to minus infinite to infinite x of k e power jk omega naught t whole star. This is by taking the conjugates on both sides for synthesis equation. See, in the right hand side, we can see the x of k with the star becomes of conjugate x star of k. And this exponential is a positive exponential. With this conjugate, the positive exponential becomes a negative exponential here. Understood, my student? Here, see, the sum of k equal to minus infinite to infinite x of k e power jk omega naught t whole star, and x of k with this star becomes of conjugate of the signal or the Fourier coefficient, and positive exponential becomes of negative exponential. X star of t is equal to. Now you can substitute this equation in power p is equal to 1 by t. the integral minus t by to the t by 2 x of t, x star of t is replaced with this signal. The sum of k equal to minus infinite to infinite, x star of k e power minus j k omega naught t. Already we have here the dt. So that is in the next line, next page. So now the p is equal to 1 by t, the integral minus t by to the t by 2 x of t, x star of t replaced with the sum of k equal to minus infinite to infinite, x star of k e power minus j k omega naught t dt. Now rewrite this expression. The p is equal to, see here, the p is equal to 1 by t, the integral minus t by to the t by 2. I'm taking the x of t, and here also the t function is there. Take the e power minus jk omega naught t and the dt with respect to dt, whole multiply with the x star of k, the conjugate of Fourier coefficient. You see here the sum of is also there. The sum of k equal to minus infinite to infinite x star of k as another function. See, within the first parenthesis, the equation becomes of 1 by t, the integral minus t by to the t by 2 x of t e power minus j k omega naught t dt as x of k only. I got the analysis equation saying that 1 by t, the integral t x of t e power minus j k omega naught t dt. Now this total within the parenthesis what we have becomes of x of k. This is x of k. So sum of k equal to minus infinite to infinite x star of k, and this function as x of k. We already know the combination of one complex function and the real function becomes of squared magnitude. The sum of k equal to minus infinite to infinite, the squared magnitude of x of k. The power average power p is equal to, we got a sum of k equal to minus infinite to infinite, squared magnitude of x of k. All right, that only have to prove the Parseval's equation. Let's see here. If x of t is a periodic power signal with Fourier's coefficient x of k, then average power in the signal is given by the sum of k equal to minus infinite to infinite, the squared magnitude of x of k. We prove that by taking the power signal p is equal to limit t tends to infinite 1 by t, integral minus t by to the t by 2 x of t square. If it is a periodic signal, that becomes of squared magnitude of x of t. The squared magnitude of x of t also written as x of t into x star of t. By using the synthesis equation, substitute x star of t with sum of k equal to minus infinite to infinite, x star of k e power minus j k omega naught t. After substituting in the power, p is equal to 1 by t, the integral minus t by to the t by 2 x of t, the sum of k equal to minus infinite to infinite, x star of k e power minus j k omega naught t dt. And rewrite this expression as p is equal to k terms in one side, that is sum of k equal to minus infinite to infinite x star of k, and remaining t terms in the other side, 1 by d the integral t, x of t e power minus jk omega naught t dt. And this total function, has analysis equation saying the x of k is equal to sum of k equal to minus infinite to infinite x star of k into x of k. We know already the x of k, x star of k represented as squared magnitude of x of k. So now what is the significance of Parseval's theorem is power of the signal can be obtained by squaring and adding the magnitudes of Fourier coefficients. By squaring and adding the magnitudes of the Fourier coefficient. That is the significance of the Parseval's theorem. It is also somewhat important one with convolution in time and the multiplication in time. It is also called as modulation in time. The last property in the Fourier series, that is the ninth one, symmetry properties. These are not the properties, they simply have the formulas. The first one is, if x of t is a real, given the time signal is real, the frequency signal x star of k is equal to x of minus k. Symmetry for the negative values also. X star of k is equal to x of minus k. If that same signal is imaginary, if x of t is imaginary, then the conjugate of x star is nothing but conjugate. The conjugate of the frequency coefficient or the Fourier series coefficient in frequency, x star of k is equal to minus x of minus k. For real terms of t, the positive value will get, and for imaginary terms, minus x of minus k. Okay. And third one you can see here, the x of t is a real and even also. It is a real, x star of k is equal to x of minus k. If x of t is real and it is also the even, then imaginary of x of k is equal to 0. When x of t is real, imaginary of Fourier series coefficient x of k in frequency, imaginary of x of k is 0. If x of t is real and odd, the same thing here. If x of t is real, if it is even, imaginary is equal to 0. If x of t is real and odd function, then real x of k is equal to 0. So these are the symmetry properties. If x of t is real, x star of k is equal to x of minus k. If x of t is imaginary, then x star of k is equal to minus x of minus k. If x of t is real and even, imaginary of x of k is equal to 0. If x of t is real and it is odd, then real of x of k is equal to 0. So totally there's 9 properties there in the Fourier series. So what are the similar properties in the Fourier transformation also? For the coming, after this completion of the Fourier series, we are getting in the Fourier transformation. In the Fourier transformation also same thing, linearity property, time shift property, frequency shift property, scaling property, time differentiation property, Parseval's theorem, and convolution time and the modulation time also the same. But don't confuse that. If they ask prove the property or prove the linearity property of Fourier series, means you have to write in the Fourier series only. And mention, or you can prove the property of linearity property of Fourier transformation, means you have to see that Fourier transformation only. The proof is same for Fourier series, Fourier transformation, and also the last 2 units also we have, that is the transformation and the Laplace transformation. So as per for third year students of R16, but second year students it is both the same. But in that also, the name of the properties is the same. The linear, T, time shift, frequency shift, time differentiation, convolution time, and the convolution modulation or the multiplication. The naming is different, but you have to prove by using the Fourier series, by using the Fourier transformation, and by using the Laplace, and by using the Z transformation. Understood? These are all, it is converting of time domain function to the frequency domain functions. Okay. Let us see some examples on the Fourier series. The first example, find the trigonometric Fourier series. Find the trigonometric Fourier series for the periodic signal shown. Simply they are giving the one periodic signal and you have to find out the trigonometric Fourier series. Fourier series are classified as a three. One is trigonometric Fourier series, second one is compact trigonometric Fourier series, and third one is exponential Fourier series. All the properties we use exponential Fourier series formulas only, analysis equation, the synthesis equation. Okay, my dear students. So for this, they are asking for the given periodic signal, find the trigonometric Fourier series. What are the trigonometric Fourier series? The three. A of 0 is equal to, and A of k, and the B of k. Finding out of all the A of coefficients, A of 0, A of k, and B of k, you can substitute in the x of t equation. What is the x of t is equal to A of 0 plus A of k with coefficient, coefficient is a cosine function, and B of k is a coefficient for the sine function. Following, my dear students. X of t having the three terms. The three terms, in that three terms, the first term is the A of 0, and second term is having a coefficient of A of k with a cosine function, cos k omega naught t. And the third term, B of k, is a coefficient for the sine function. So first of all, you can find the A of 0, A of k, and the B of k, all the terms, nothing but is the coefficients. After that, we can substitute in the x of t. But first of all, from the given table or the given figure, periodic signal, you see here, this is the exponentially decaying function from 0 to 0.5. Observe here, my dear students. 0 to 0.5. Again, it is repeated with the 0 to 1. Again, it is repeated from 1 to 1.5. And again, it is represented from same from 1.5 to the 2. And the negative real axis also 0 to minus 0.5 and minus 0.5 to 1, and 1 to 1.5. For every time period of 0.5, it is repeated. Okay, with equal interval of time. With equal interval of time. With what period here? 0.5. You see, the t is equal to here, the period t is equal to 0.5. For every 0.5, the 0.5 to 1 is a 0.5, 1 to 1.5 is also 0.5, 1.5 to the 2 is also, the period is a 0.5. And the given function is, what is the given function? X of t. Exponentially decaying function. Exponentially decaying means e power minus t. E power minus. When exponentially rising means e power plus. Okay. So these are the two given terms from the given periodic exponential signal. The t is, capital T is 0.5 and x of t is equal to e power minus t over one period. Over one period. See, what is the formula for the A of 0? We already proved the functions of the trigonometric Fourier series. A of 0, A of k, B of k. A of 0, the formula is a 1 by t, the integral t. Integral t, x of t dt. What is the integral here? Initial value is a 0, final value is a 0.5. So the integral initial value is 0 I take, and final value is a 0.5 because the time period is a 0.5. And similarly, the 1 by t here, 1 by 0.5. The x of t is negative exponential because it is a decaying from the magnitude 1 to goes to the 0. E power minus t dt. Now the 1 by 0.5, what is the integral of e power minus t? E power minus t by minus 1. The coefficient of t is here, the minus is there, the minus 1 divided by the minus 1. Lower limit is a 0, upper limit is a 0.5. Okay. So after calculating this function, 1 by 0.5 means 1 by 1 by 2. Nothing but is a 2 function. See, 1 by 0.5. If you have the calculators, take your calculators and find out the value. Here the minus is there. I'm keeping the minus here. The minus e power minus, what is the upper limit here? The minus 0.5 minus e power minus 0 is a function is equal to, that is equal to minus, what is the value here? The 1 by 0.5 means 1 by 1 by 2. Totally it is the 2. 2 into e power minus 0.5 minus anything power 0 is a 1. 1. Definitely it is a e power minus 0.5 is less than the 1 only. Less than the 1. So here the minus is there, here also the minus, greater value having the minus is there. Minus into minus definitely becomes of the plus. You find out e power minus 0.5, what is the value, and simplify this one. Definitely you'll get the 0.7869. Take your calculators and find out the e power minus 0.5 value. Definitely that is a positive value and it is less than the 1. Understood? So subtract these two functions and multiply with the 2. Minus into minus is becomes of the plus. 0.7869 is a A0 value. A0 value, A of 0 value is 0.7869. Then you go for step 2, calculate the A of k. A of k, that is the second one here, A of k. What is the formula for the A of k is equal to the 2 by t, the integral t, x of t. X of t is a coefficient of cosine function, my dear students. X of t in the cos k omega naught t dt. What is the x of t here? E power minus t, and t is equal to 0.5. So we write as 2 by t as a 2 by 0.5. 2 by 0.5. The limitations is the same, 0 to 0.5 here. X of t cos k omega naught t. What is the cos k omega naught t? Omega naught is equal to 2 pi f. We already know 2 pi f. F is a inversely relation between of the time is 2 pi by t. 2 pi by t. What is the t here? The time period is a 0.5. So 2 by 1 by 2. Total it is a 4 pi. So omega naught is equal to 4 pi. Substitute here cos k 4 pi into t dt. And x of t is equal to e power minus t. X of t is equal to e power minus t cos 4 pi kt into dt. Now directly if it is a e power minus t, you can apply the integral, or otherwise integral cos is there, you can directly apply the integral. Integral cos is a sine, or integral sine is a cos, with some change of the positive and negative. But it is a combination of exponential and cosine function. Combination of exponential and the cosine function. See here the trigonometric function e power ax cos bx into dx. Integral e power ax cos bx into dx. So these are equation you get in the M1 or M2. We already learned in the first year, or in the trigonometric series, trigonometric function, integral e power ax cos bx. So what is the a here comparing of these two functions? A is equal to -1, as a t is x here. A is -1, and the bx, x here the t, so what is the b here? 4 pi k. So b is equal to 4 pi k. The formula for the e power ax cos bx dx is equal to e power ax by a square plus b square whole multiply with a into cos bx plus b into sin bx. Once again you can see the integral e power ax cos bx dx is equal to e power ax by a square plus b square whole multiplied with a cos bx plus b sin bx. Substitute the values of a as -1 and the b as 4 pi k in this equation to get the a of k value. Let us see. I am using this one. E power ax cos bx is equal to the same value. A of k is equal to 4 whole multiplied with e power a. What is the a here? -1. So e power -1 into t by a square plus b square. What is the a here? -1 whole square is a positive value plus b square. What is the b? 4 pi k whole square, and whole multiply a into cos bx. Okay, a into cos bx plus b into sin bx. So a, what is the a here? -1. A is -1 cos 4b 4 pi k into t plus b sin bx. What is the b here? 4 pi k sin bx 4 pi k into t. Okay, and totally it is an integral of e power ax cos bx into dx, as with the limits of t here 0 to 0.5. 0 to 0.5. So first of all, you can substitute the upper limit in this equation wherever the t is there. 4 into e power minus t. E power minus t, upper limit is a 0.5. E power minus 0.5. 1 plus 4 pi k whole square whole multiplied with minus cos 4 pi k. The t is 0.5 here. 4 pi k sin 4 pi k. Here also the t is there, 0.5. It is only the upper limit. But to substitute the lower limit, use the minus e power minus 0 or plus 0, whatever it is the same only. E power minus 0 divided by 1 plus 4 pi k whole square whole multiplied with the minus cos 4 pi k into 0 plus 4 pi k into sin 4 pi k 0. And this equation is for upper limit, and this equation is a lower limit equation. Simplify this one. Okay, e power minus 0.5. What is the e power minus 0.5 value? Is 0.606, my dear students. 0.6064. You can multiply this 4. In both the cases, the denominator is the same. 4 by 1 plus 4 pi k whole square. And the cos, here the 4 is there. 0.5 is 1 by 2. So 1 by 2 into 4 is a 2. So minus cos 2 pi k plus 4 pi k, and here also 1 by 2, it becomes of sine 2 pi k. What about the second term here? Cos 0 is equal to, what is the cos 0 here? Cos 0 is a 1. Cos 0 is a 1 and sine 0 is a 0. So the last term what we have here, it is a 0 value. 0 means 4 pi k sine 0 is a 0. And this value is a 1. Minus, and here the minus into minus is there, becomes of plus. Following my dear students. So individually you can observe here. It is a minus, minus into minus is becomes of cos plus, and cos 0, the value is a 1. And sine 0 into 4 pi k, it becomes of totally the 0. These are the two terms of the lower limit values. And upper limit also you can observe here. The first one is minus cos 4 pi k into 0. 4 pi k into 0 means the value is here, it is a 1, already said. Cos 2 pi k, minus cos 2 pi k plus 4 sine 2 pi k. What is the sine 2 pi k? Sine 2 pi k is also the 0 itself. Following, sine 2 pi k is a 0. Only the remaining term, here the value is 1, and this value is a 0, and this value is a 1, and this value is a 0. Okay, 1 here, and this one is a 0, and here the 1 and the 0. Now this 0.606 is multiplied with 1, we get the minus 0.606, and this value is a 0, here the 0, and this value is a 1 and 1, and this value is a 0, we have the 0. Whole multiplied with the 4 by 1 plus 4 pi k whole square. Simplify it is, denominator is the same, 1 plus 4 pi k whole square, 4 into 1 minus 0.606. You find it this one value by using your calculators. 1 minus 0.606 multiplied with the 4, the totally the A of k is equal to 1.576 whole divided by 1 plus 4 pi k whole square. Understood? So these are 4.606 is only multiplication factor of these two values, my dear students. Don't multiply this 4.606 for this one. Is only the multiplication factor of here e power minus 0.5 is the first term all. But the second term e power 0 is a 1. E power 0 is a 1. So here the value is 1. Denominator is the same for the two functions. Is a one factor, is another one. Only the e power minus 0.5606 is multiplication factor of these two terms only. So I multiplied 0.606 with 1 as minus 0.606. Sine 2 pi is a 0 value, and 1 into cos 0. Minus into minus is a plus, and sine 0 is a 0. So 1 into 0 is a 0. Okay. So we got A of k is equal to 1.576 whole divided by 1 plus 4 pi k whole square. We got A of 0 and A of k. Similarly, the third one you can find out B of k also. What is the B of k here? As of x of t is a coefficient of sine function. So B of k is equal to 2 by t, the integral t, x of t sine k omega naught t. Here also the omega naught is a 2 pi. f 2 pi by t. T is 0.5. So what 2 pi by the 1 by 2. Total it is a 4 pi. So omega naught is becomes of 4 pi into t. K is already there. What is the x of t e power minus t? And the limitations is from 0 to 0.5 as given of exponential signal, and remaining is a periodic signal, so 0 to 0.5, and is the value is 1 and x of t. As a periodic signal, it is repeated as of exponentially decaying function. So 2 by 0.5 with the limitations of 0 to 0.5 e power minus t sine 4 pi k into t dt. Sine 4 pi k into dt. Here also, but you see here, now use this formula e power ax sine bx. E power ax sine bx. Why? It is a e power minus t sine bx. Here also a is equal to minus 1, b is equal to 4 pi k. The equation is different. E power ax sine bx is equal to e power ax by a square plus b square into a sine bx plus b sine b cos bx. The interchange of this one. Okay. After the simplification, the 4 into integral 0 to 0.5 e power minus t sine 4 pi k into dt can apply the integration as of substituting of upper limit and the lower limit. Finally, we'll get 6.32 pi k whole divided by 1 plus 4 pi k whole square. For a of k, we'll get the constant value 1.576, and for the b of k, you get the variable of k, 6.32 pi into k whole divided by 1 plus 4 pi k whole square. All these three terms, a of 0, see we got the a of 0 is a 0.7869, and a of k is equal to 1.576 whole divided by 1 plus 4 pi k whole square, and b of k is equal to 6.32 pi k whole divided by 1 plus 4 pi k whole square. All the three terms, the three equations you can substitute in the x of t is equal to, I already told, the Fourier series having the coefficients a of 0, a of k and b of k. A of 0 is a constant, a of k is a coefficient of cosine function, and b of k is a coefficient of a sine function. So x of t is equal to a of 0 is a 0.7869 plus sum of k is equal to 1 to infinite. Why it is a 1 to infinite we got here? When k is equal to 0, cosine function is equal to 1. When k is equal to 0, sine function is a 0. So there is no any value for the k is equal to 0 for the sine function. For the cosine function we have 0.7869. So k is equal to 1 to infinite. The a of k coefficient we got 1.576 whole divided by 1 plus 4 pi k whole square cos k omega naught t plus sum of k is equal to 1 to infinite b of k here. B of k is equal to 6.32 pi k 1 plus 4 pi k whole square into sine function, sine k omega naught t. This is a trigonometric Fourier series equation after substituting the a of 0 coefficient, a of k coefficient and the b of k coefficient, my dear students. Understood? It is very important example, my dear students. Coming to the next one, next example you can see. Now, in the given example, there is a periodic rectangular wave. Periodic rectangular wave. Here only the rectangle wave is from minus t1 to the t1. and from minus t by to the t by 2, minus t by to the t1 here it is a 0, and t1 to t by 2 is also the 0. So total period here you can take as minus t by to the t by 2. Total period is minus t by to the t by 2. In that, the given x of t signal, the t1, the magnitude of t is less than the t1 is a 1, and 0 for t by to the t by 2 means less than this value and greater than this value. So t1 is less than the t, means nothing but the t value is greater than the t1, and the t is less than the t by 2. So less than the t by 2 value is a 0. These two factors is a 0, only in between the t1 and the t, minus t1 to the t1 is 1. Understood? This is the given x of t, and they are saying it is a periodic signal also. So again it is repeated from t by to the value here, and the minus t by to the minus t by 4 here is repeating. So for every same interval the signal is repeated. We can call it as a periodic signal. We can call it as a periodic signal. Now, here also you can find out a of k, b of k, and a of 0 also. To find out the Fourier series, not the Fourier series, so you can find out the trigonometric Fourier series. But they are asking that let us determine the Fourier series coefficients. Only they are asking, it is not the trigonometric Fourier series. They are asking to find or to determine the Fourier series coefficients. Fourier series coefficients, that is a of k and a of 0 and the b of 0, b of k also you have to find out. You can substitute all these coefficients in x of t equation, then it becomes of a trigonometric Fourier series. Okay, using this signal x of t, the first of all I am finding out the Fourier coefficient a of k. What is the formula? 1 by t, the integral minus t by to the t by 2, x of t e power minus j k omega naught t dt. E power minus j k omega naught t dt. Why I am taking here the minus t by to the t by 2 means this totally the signal is repeated from minus t by to the t by 2. Minus t by to the t by 2. So minus t by to the t by 2. What is the x of t here? One function as of 1 by t, the integral minus t1 to the t1. So within the range minus t by to the t1 is a 0 and t1 to the t by 2 is a 0. Only the remaining part what we have from minus t1 to the t1 is a 1 here. Following my dear students, this value is a 0 here and this value is a 1 and this value is a 0. Within this total period of minus t by to the t by 2, the x of t value is a 1 only in between of minus t1 to the t1 only. So I am rewriting this expression as 1 by t minus t1 to t1. X of t is a value is 1 now. The remaining minus t by to the t and t1 to t2. So totally the integral becomes of one time is minus t by to the t to the minus t1 plus integral minus t to t plus and integral plus t to the t by 2. There is a 3 integrals we have within this total limitation. Minus t1 to the t1 minus t by to the t1 is a 0. And for the last integral also, t to t by 2 is also 0. Only this in between of minus t to the t is a 1. So I'm not taking the remaining 2 parts here because these 2 are the zeros. Only we have 1 from minus t1 to the t1, 1 into e power minus j k omega naught t dt. Alright. What is the e power minus j k omega naught t dt? Integral as e power minus j k omega naught t, and t coefficient you can write it in the denominator. J k omega naught jk omega naught, and here the t is there, that t, jk omega naught t, and the minus also there, the minus. So minus 1 by jk omega naught t, e power minus jk omega naught small t, with the limitations of t1 and minus t1 is a lower limit. Substitute here the upper limit e power, see something went wrong here. So a of k is equal to, we got minus 1 by jk omega naught t multiplied with what is the upper limit, e power minus jk omega naught t1, e power minus jk omega naught capital T1, that is upper limit, minus lower limit is e power, here the minus and here also the minus, minus into minus is a plus, jk omega naught T1. Following. And now here the minus, you can multiply this minus with these two functions, minus of e power minus negative exponential, and minus into minus is a plus for the positive exponential. So whatever we got, the same thing here. Okay, so positive exponential is a plus, negative exponential is a negative. By 2 is also there, and here if I am taking that to get it is a 2, multiply the 2 here, and j, whatever here the j I take here, so it is in the form of e power jx minus e power minus jx by 2. According to the Euler's rule, e power minus j by 2j is a sin x. Sin x is equal to, or cos x is equal to, we already know, jx plus e power minus jx by the 2 is a cos x, my dear students, according to the Euler's rule. So see here, e power j x, what is the x here? K omega naught t1 minus, here also see the x is k omega naught t1 by 2j. Total parenthesis, you can write it as sin x. What is the x? K omega naught t1. So here the 2 is multiplied to k omega naught t. So a of ak is equal to 2 sin k omega naught t1 whole divided by k omega naught t1. Don't confuse here, both are not t. In the upper here the t1, and in the lower it is a time period. It is a time period, the total time period. 2 sin k omega naught t1 by k omega naught t. And another coefficient when the k is equal to 0, to get it is of a of 0, k is equal to 0. What is the sin 0? Sin 0 is equal to, the a0 is equal to 1 by t, the integral minus t1 to the t1. I am not substituting in the directly the k value here itself. If it is the case k is equal to 0, you can substitute sin 0 becomes 0. Okay, but a of 0 is not the 0 value. You can substitute in this equation, my dear students. In this, not in this function. E power j minus j k omega naught t. The k value is a 0 means e power 0. What is the e power 0 value is 1. E power 0 is a 1. So a naught is equal to 1 by t integral minus t1 to t1 1 into dt. What is the integral of dt? T1. So 1 by t integral t, integral 1 into dt is a t, upper limit is a t1, lower limit is a minus t. So 1 by t, substituting of t1, minus of minus t1. becomes plus 2t1 by the t. So a of 0 is equal to 2t1 by the t. So the two coefficients we got a of k and the a of 0. They're asking that the given periodic rectangular wave, determine the Fourier series coefficients. Fourier series coefficient, that is a of k and the a of 0. Following my student. And another example you can see here, periodic impulse train. Periodic impulse train is given. Consider the signal x of t. Consider the signal x of t. The sum of k equal to minus infinite to infinite delta of t minus k into t. The fundamental period of x of t is at t. The Fourier coefficients are a of k is equal to 1 by d the integral minus t by the t by 2 delta of t dt. What is the delta of t? Is always a 1, my dear students. Impulse function. We already know the impulse function, the characteristics is like this. Delta of t is 1 at t is equal to 0. And the remaining functions, so minus infinite to infinite, delta of t dt is equal to 1 for t is equal to 0 and 0 for t not equal to 0. This is the equation for the impulse function, and the characteristics having only 1 at t is equal to 0. The remaining all the values is a 0 zone. This characteristics is similar to that of continuous and the discrete also. Discrete is also showing like this one, because having only the one value, but the variable is difference. N, when n is equal to 0, the magnitude is the 1. Okay. So the delta of t, even if it is a shifting operation also, the value is the same. Suppose if I am shift this function, delta of t minus 1, one sample is shifted. What happens? 1 will get at t is equal to 1. Because at t is equal to 0, the value is 1 here. At t minus 1 means at t is equal to 1, the magnitude is a 1. And 0 is a 0, 2 is a 0, and minus 1 is also 0, minus 2 is also 0. This one sample we have in the impulse function, and it is shifted towards the right side as one sample. So delta of t minus kt, even that also is having only the 1 in that case also. If suppose the delta of t minus 2 also, here also having the value is only the at 2. At 2. Remaining all it is a zeros. 0, 1 and the minus 1 and the minus 2 is also zeros. Even in the shifting, even if you're not shifting the impulse function, having the value is 1 only. Delta of t is equal to 1. In the period of minus t by the t by 2, the impulse train. Using that, the a of k is equal to 1 by t, the integral minus t by the t by 2, delta of t dt is equal to, delta of t dt is equal to, as delta of t is a 1, 1 by t, 1 into dt, means a t here, minus t by the t by 2, not the minus here, the plus, minus t by 2, substitute that, 1 by t into plus t by 2, minus of minus t by 2 is t by 2 as a t, 1 by t into the t, tt get cancelled. Okay, tt get cancelled. Here it is not the one. So for any value of k, it is not 1 by t, my dear students. This value is 1 by t is already multiplied, and after taking this function as 1 into dt, it is a t by to the minus t by to the value is t, and tt get cancelled. The value is a 1. A of k is equal to 1 for any value of k. But there is no any k here. For any value of k, the a of k is equal to 1 only. A of k is equal to 1. Understood? So we did the 3 examples. One is find the trigonometric Fourier series of the periodic signal shown for the exponential pulse. And the second one is find the Fourier series coefficients for rectangular wave, and find the coefficients, Fourier series coefficients for periodic impulse train. All right. And the last here, a brief description about the properties of the Fourier coefficients. So the first property, the linearity property. In that x1 of t and x2 of t are the two signals. x1 of t is a of k and x2 of t is a p of k. Then that is a Fourier coefficient, my dear students. Fourier coefficient. Actually, it is a x2 of k. x2 of k. So these two signals are, one is after the substituting the Fourier, applying the Fourier series is a of k, applying the Fourier series is a b of k. A x1 of t plus b x2 of t, the Fourier series is a of k, actually it is x of k, plus b x2 of k. x2 of k, now I am saying here it is a b of k as continuous time function. If it is a discrete time function, x1 of n is a of k, x2 of n is b of k. The linearity property saying a x1 of n plus b x2 of n, applying the Fourier series here to get a x1 of k, actually I am assuming here the a of k, plus b x2 of k, actually it is a b of k as of linearity property. The second one, time shift property. What is the time shift property? X of t minus t naught. Applying the Fourier series, here x of k, instead of x of k, we are taking the coefficients or a of k. Remember that. A of k into e power minus jk omega naught t naught. In the discrete time function, x of n minus n naught is a of k, e power minus jk. You see here, the difference between of angular frequencies in time, continuous time and discrete time function is difference. Both are angular frequencies, both are 2 pi f only, but representing is different here. Symbol is different, omega naught angular frequency, and here also the omega naught only, and instead of t naught it is a n naught. Time shift property. And next one, time reversal property. What is a time reversal? X of minus t, applying the Fourier series, a of minus k, a of minus k. As in the discrete, x of minus n is a Fourier series, a of minus k, a of minus k. We already know the y of t is equal to x of minus t, the time reversal property. And k is equal to minus m. It changes as x of minus t is a Fourier series of a of minus k. The a of minus k is a x of minus k there. Understood? Now conjugate or conjugation, x star of t is equal to a star of minus k. X star of n is the, not is equal to, you can don't call it as is equal to the Fourier series pairs. X star of n is a Fourier series a star of minus k. And multiplication factor, a x of k is a of k, y of t is a b of k. Multiplying means here convolution. Multiplying means is a convolution. The convolution is a sum of k equal to minus infinite infinite, a of k, b of n minus k actually, or k minus t, because it is a time, continuous time function. And last one is a Parseval's equality. Parseval's equality, according to the average power 1 by t the integral t, the squared magnitude of x of t dt is equal to the sum of k equal to minus infinite to infinite. Actually it is a squared magnitude of x of k. Squared magnitude of x of k. Instead of x of k, I am keeping the a of k here as a coefficients. In a discrete time function, instead of 1 by t, it is now the 1 by n. The sum of n is equal to n. The squared magnitude of x of n is sum of k equal to n, squared magnitude of a of k. Understood? Now with this, the Fourier series in the second unit, the Fourier series properties and the sum of the examples of the Fourier series is completed. Half part of the second unit, and remaining half part is the Fourier transformations. Okay, you see in that in the next class, tomorrow's class, what is a Fourier transform and what are the different types of properties are there in the Fourier transformations. Okay, my dear students. Thank you. Thank you, Anand.